Okay, so this topic is on the packet walk, okay, for the firewall. So we have already done few things here: show interface IP brief, this one, show nameif, okay, show running NAT. Okay, so let's say for example, if you are on outside internet and you are accessing this, okay, you are accessing an IP address of this object, so show run object, so if you are accessing, where is it? Yeah, if you are accessing the interface IP, which means show nameif, I think it's, just give me a minute, show running interface redundant 2. So if you are accessing this IP address which is outside as per this rule, and you are accessing it on port 8100, you should be able to reach this server, and this server is in partner zone, right? Because this is a low to high traffic, a traffic that will be coming from low security zone to high security zone, you would need an access list. Okay, so we already have an access group applied on outside interface in incoming direction or inbound direction. Okay, so let's check. The ACL here. Okay, so this is the server. Okay, now what you want to see is when you initiate a connection from outside, so as a part of this topology over here, so what I'm going to explain you is packet walk for this traffic. So you would be initiating a traffic from here, okay, that will go all the way to the firewall outside interface. You have an ACL here. After checking against ACL which says permit, where the action is permit, the traffic will get in and it will reach here. What happens in between on the firewall, that's what we have to check here. Okay, so for that, one is you do this portion, go to this and say should be 8100. Right, okay, so this is okay. So you should see show NAT partner outside here. You see a hit count over here, okay, and show access list. Last time the hit count was 1, this time the hit count is 2. Last time when we checked this ACL, the hit count was, now we initiated the connection, so the hit count is, but what has actually happened? Finally, if you see show connection, you actually see a connection as well here in the table. So what has happened? Which portion has come first? Which portion has gone later? Okay, so if you see your connection, it's basically here. You see the flag as U and B, and capital U, if you look at, your capital U means up and your capital B means the initial packet was from outside. That's what we did, right? We telnetted from outside to inside, is it? Okay, and whatever you send further, for that you would be able to see. Okay, so we go back here and we say so jump back here. Yes, there were no, this is not the one. Okay, that connection is, because it's closed, it's removed. I eventually won't be able to see it here as well. Yeah, okay, never mind. Show, what we were supposed to check is show NAT, the hit counts over here, translate and untranslate hit counts here, and show access list. Okay, now how it's processed. So one very good way of getting this is use this command, packet tracer input. The packet is coming from outside interface, it's a TCP packet, okay, which is coming from okay, the port number, you can give some port number. Let's see what it was here. 56748, let's say, for example 56748, and it's coming to your server, which is 1111, port number 8100. Let's see what will happen here. Okay, so actually what we expect here in this case is something like this. Okay, so as a part of this, what we expect is when you receive the packet, you receive the packet over here, this portion,
outside interface.
so your ingress interface is outside in this case. You check, do you have an existing connection? In this case, no, right? So you go to step 4. Step 4, you check the translation rule. Now how do you check the translation rule? This is an interesting part here. When the packet is coming from out towards you, the packet actually contains an IP address called 1111, and there is a port number 81. This actually goes and matches one of your translation rule, which is, you can see it here. So the very first thing what happens is you check it, then you do what? Untranslation. Do you see this? You do untranslation. Okay, so from 111.8100 you change the IP address to the original IP, the real IP, which is 172.16.10.100/80. Real IP, real port number, as per this particular rule. Okay, then we have already configured an access list on the outside interface, right, which says if the traffic is coming, and if it happens to be TCP traffic coming from anyone from internet, but if it is coming to one of my host .100 and port number is 80, which matches here. So after translation, the value in your packet is this, which matches the ACL, and the ACL action is permit. Okay, so it matches the rule, goes to ACL. ACL matches, yes, then goes to inspection. Okay, after that what happens? Comes here, right? At this point, what do? Natting. If there is supposed to be a translation happening, do it here. Okay, then what next? Sorry, inspection. Yes, HTTP inspection is supposed to happen. Next what? NAT. Okay, as per this rule. Okay, now you change the packet. There's no QS. Okay, there's no modification in IP options and everything. Finally you create what? Flow. I showed you the connection entry, remember? I'll do it again and I'll show you. So finally you create a connection entry in the table, so that so this is what you're doing for the first packet, remember? Okay, you create the flow, okay, and you dispatch it to the next modules, which in which case it comes to egress interface, which you already know from this portion here, the egress interfaces, partners. You can do a route lookup. Okay, where is that IP address? 172.16.10.100. Do a route lookup, do an ARP. Okay, so at that point do an ARP. Okay, get the MAC address. Okay, rewrite the Ethernet header at this point and dispatch the packet. Do you get this? So only portion left is that connection portion, right? So for that, what you can do is you can check it here, flow creation, right? So for this understanding, show connections. We don't see that TCP connection, but you can understand it by doing this part here. So here is this portion, and you should see. So as a part of that whole traffic or packet flow, remaining packets are coming based on this. Do you get this?
The flag will be still the UPM.
Okay, all remaining packets are going to come by looking at this connection entry. Okay, similar to this, how the ACLs work on firewall and how the ACLs work on router are different. I'll do a small change over here. I'll go to this router, which is your partner router over here. I create an access list here, IP access list extended. Again, give a name, let's say inbound ACL. Okay, I say permit TCP traffic from anyone to anyone, let's say EQ port number, or let's do this. Let me do this. Permit TCP from anyone to anyone on port number 23 and port number 80 and port number 21, and yeah, and finally permit IP any, just to see the hit counts. Interface F00, you go and say IP access group, name of the ACL inbound, what is the name? Inbound ACL, direction in, show IP access list. I don't know, actually, let me deny this because I don't want to see a hit count over there. No, and I say deny IP any. Show IP access list. Okay, this is cool. So what you see here is you see 3 entries here, right? And now what I do is I send something abc dot. What do you see? 45 matches. Okay, let's redo this and try to observe the things. So how ACLs behave on firewall are different from how it behaves on Yes. Okay. Very first on firewall, whenever you create an ACL, it's always named and it's always extended ACL. Example, access dash list ABC permit. Do you see? TCP any EQ. I did not say that it has to be, but if you see this, I did not say that it has to be extended, but it happens to be by default. It's now, it doesn't mean that firewall doesn't support standard ACLs. It does. For that you have to manually say that please make it as or configure it as okay. I already have ABC, sorry, my mistake. One of the difference. Do you get this? Second thing, like I showed you in the example here, we applied the ACL to router, isn't? You have to go to interface subconfig mode and then apply the ACL. Okay, on firewall the ACLs are applied in the global configuration mode. You do not have to go to interface subconfig mode. Firewall, most of the things we do it globally, not under the interface. So by default the ACLs are named and extended ACLs. Second thing, the ACLs are applied globally, not under the interface. Third, your ACLs uses regular mask. Okay, firewall, most of the places, almost all the places we use regular mask. There's no concept of wildcard mask. Routers, there's a concept of wildcard mask. Okay, and the fourth one, which is one of the biggest one which impacts your performance, is this. I want you to have a look at this. Show access dash list. Where is the web traffic? This one? This for DMZ partner server, right? Is it? How many it counts? 4. I'll initiate a connection. Hopefully there's no connection in the table. There's no existing connection in the table, right? So this time if you initiate a connection, this connection will be coming from where? From low towards high security, which means it has to come through an ACL. Right? We'll monitor. It's going to be same connection. What I've done is I've applied an ACL here on the router. I've applied an ACL here on the firewall also for the same traffic, web traffic. But we'll see how many hit counts do you get on firewall and how many hit counts do you get on router, and why so. Okay, so let's get started. So I go to the ISP here. I begin a connection. It's open. It's there. Connected. Get back to your firewall. Very first, check this entry, line number 5. There should be a hit count. Hit count of 1. There's increment of just 1. Okay. Now you see what? Look at the connection table. A connection is created now on. Okay. Now get back to the router. Last time around on your router, how many hit counts were there? 45. Let's see how much it has gone now. It has gone to 54 now. Right? Now if I send something again, get index.html on router, again this has gone from 54 to exactly. But you see over here, see on your firewall, it's still 5, man. So what do you learn? on firewall, because of the traffic flow here, how the packet is processed. That's the reason. On the firewall, very first time when packet comes here, there's a connection. No worries. Continue going. At this point, you get an ACL. Good. From ACL, what do? Check the entry. Only the first packet. This whole thing happens for the every packet. So in this case, for the very first packet, ACL hit counts, increase it by 1, so it becomes 5 here. ACL hit count increased by 1. Good. But simultaneously one entry gets created in the connection table. Now the remaining packets of the same flow comes like this. Existing connection, yes, jump and come here. You don't encounter. That's why on firewall there is no hit count. It's still 5. For that whole connection now it will be what? Same count. Until unless you disconnect and reconnect or reinitiate a new connection. But same thing doesn't happen on router. Okay, on router for every packet ACL is checked. Performance. This is faster. Okay, all the subsequent packet of the same flow are forwarded by looking at this portion. Do you get this? Okay, that's why for the same ACL you see 2 different hit counts on 2 different platforms. It's the same traffic, it's the same web traffic coming to this router, partner router, but still you see different hit count. Why? Because here for every packet ACL is checked. There only for the first packet of the flow ACL is checked. Okay,
while troubleshooting,
okay, fine. So this is your complete packet walk through the ASA. Though there are modifications when you go to ASA with firepower services, or when you go to firepower threat defense, which is altogether a different operating system and architecture. Okay, but this one is a good fit for your ASA. Okay, so this was only from the perspective of packet walk through ASA, not for your with your firepower services or for your firepower threat defense image. Okay.